In Lesson 6, we're going to look at another scenario, just like we did in Lesson 1, except this time we'll be using batting averages. In this lesson, we'll be going from fractions to decimals to percentages. Here's the scenario. Greg, Hannah, Iris, Javier, Kevin, and Larry play in a baseball team. Early in the season, they have the statistics shown below. These are the number of hits that each player has, and these are the number of at-bats that each player has. In baseball, an at-bat is when it's your turn to bat against the pitcher. A hit is when you hit a fair ball and are able to get to first base safely. And by the way, walks don't count as at-bats, and errors don't count as hits, but you don't really need that information for this problem. Let's take care of part A. It says write the batting average as a fraction. So if you look at Greg, he had 2 hits out of 7 at-bats. So his batting average as a fraction is 2/7. Hannah's batting average is 4/9. Iris is 3/5. Javier is 1/4. Kevin is 2/9. And finally, Larry is 3/8. And now, just like in Lesson 1, students will decide who they think has the highest batting average. But before they do, I'll give them some information to think about. So maybe Hannah has the highest batting average because she has the most hits out of anyone on her team. However, since she has 9 at-bats, that means she got called out 5 times because 9 minus 4 gives you 5. If you look at Javier, he's only been called out 3 times because 4 minus 1 gives you 3. But then again, he only has 1 hit. So how do we decide who has the highest batting average? And just like before, after a couple of minutes, students will see that it's really difficult to tell who has the highest batting average. So we're going to work on some conversions to make it easier. Take a look at letter C. Here it says convert the batting averages from fractions to decimals, and we're going to carry them out to 3 decimal places. And since this involves long division, I'm going to do some of the demo off screen. Here are the division problems worked out for letter C. And you'll notice that this division problem terminated after 1 decimal place. This one terminated after 2 decimal places. And this one terminated after 3 decimal places. The other 3 problems, for Greg, Hannah, and Kevin, are actually non-terminating, and these division problems will keep going on forever. But we just need to work it out to 4 decimal places so that we can round it to the 3rd decimal place. So let's take a look at Greg's example. Here we worked it out to 4 decimal places, and we're going to round it to the 1,000th place, to the 3rd decimal place. So if this number is 5 or greater, we can round it up, otherwise round down. So since 7 is greater than 5, we're going to round this to 0.286. And you see I have it written here. When baseball works with batting averages, they leave out the leading 0. And that's why you'll notice here that there's no leading 0. Now look at Hannah's problem. We worked out her problem to 4 decimal places, and we're going to round it to the 3rd decimal place. So since this number is less than 5, we're going to round down, and our answer is going to stay 0.444, or 444 hundredths. And you'll see here, I have it written down. Now let's look at Iris. Her batting average came out to 0.6, or 6/10. But in baseball, they work it out to 3 decimal places. So I'll add a couple of trailing zeros, and this is her batting average. And that's written down there. Next up is Javier. His batting average is 25 hundredths, but again, we're going to work it out to 3 decimal places. So add another trailing 0, and here's his batting average. Next up is Kevin. We worked it out to 4 decimal places, and since this 4th digit is less than 5, we're going to round down, and his batting average is 0.222, or 222 thousandths. Now let's take a look at Larry. Conveniently, his batting average terminated after 3 decimal places. So this is his batting average right here. So this is how we read these numbers in mathematical terms and in baseball terms. This is 286 thousandths, 444 thousandths, 600 thousandths, 250 thousandths, 222 thousandths, and 375 thousandths. In baseball, they read it a little differently, and this is how they do it. They don't say the thousandths, and they just read this as 286, 444, 600, 250, 222, and 375. Now that we've converted the batting averages from fractions to decimals, let's see if they're easier to work with. Here, notice that we have everyone's batting average written as a decimal to 3 decimal places. So who had the highest batting average? And now it's much easier to see that Iris had the highest batting average with a 600. So we'll write down Iris. Who had the lowest batting average? And that would be this batting average here, and that belongs to Kevin. Let's answer the last question. Why is it now easier to answer these questions? And it's much easier because all the batting averages are expressed as decimals and they're all carried out to 3 decimal places. One important thing to point out. This symbol here that looks like a wavy equal sign means approximately equal to. So 2/7 is not exactly equal to 286 thousandths. It's approximately equal to 286 thousandths. Now for the last step, box E. Convert the batting averages to percentages to 1 decimal place. So here we have 286 thousandths, or in baseball terms, 286. Let's move the decimal point 2 places to the right, and we'll end up with 28.6%. Write it down. Next, we have 44.4%. Here, move the decimal point 2 places to the right, and we'll end up with 60%. Next, 2 places to the right, and we have 25%. Two places to the right gives us 22.2%. And finally, move the decimal 2 places to the right, and we have 37.5%.